Alright, so it will help for us to understand then how do we go through and actually sketch the graph of a rational function. And we'll just start with a few simple ones and we'll work our way from there. The steps that we should take are always pretty much the same. And it goes like this. The first thing we want to do is find our domain. The next thing we're going to do is we're going to try and find any vertical and horizontal asymptotes. We're going to outline those on the page on our graph, and then we're going to try and find any X and Y-intercepts for the graph. We're going to check for any symmetry, if any symmetry does indeed exist. We're talking about even or odd symmetry specifically. We want to determine the behavior near the asymptotes and finally get a sketch of this graph. So let's see how that works. I've got this function right here. F of x equals negative 3 over x plus 2. Make myself a little bit of room right here. Let's determine the domain. Well, in this case, this is really, really simple, right? The domain is defined by that denominator of x plus 2. So what we're going to do is we're going to sketch our graph, making sure that our denominator, x equals negative 2, is not in that domain. The next thing is we want to find our vertical and horizontal asymptote. Well, the vertical asymptote in this case is found by setting the denominator equals to 0. It happens to coincide with the domain in this particular instance, so our vertical asymptote is the line x equals negative 2. So whenever we get this effect, we're going to, at the line x equals negative 2, actually sketch in a nice vertical line. So let me see if I can do that here in some sort of reasonable way. And I just dashed that in. Okay. So that's one of my first acts, is I'm going to dash in my vertical asymptote. And of course, I'm going to try and do the same thing with my horizontal asymptote. The horizontal asymptote, well, we look at the degree of the numerator and the degree of the denominator. The degree of the numerator here is 0. A single number is a polynomial, but it's a 0th degree polynomial. And the denominator has a degree of 1. Since the degree of the numerator is less than the degree of the denominator, we always assign the line y equals 0 as the location of that horizontal asymptote. So if I'm sketching my graph, of course, I don't really have to dash in the horizontal axis, but I'm going to go ahead and do so anyways, just so I keep in mind this is where my horizontal asymptote will lie. And I'm going to label it. Y equals 0 is my horizontal asymptote. X equals negative 2 is my vertical asymptote. And I just want to keep those in mind. All right, the next is finding the X and Y-intercepts. Well, we find a Y-intercept by setting x equal to 0. And in this case, if we let x equals 0 in our original function, f of 0 is the number negative 3 over 0 plus 2, which is to say negative 3 halves. Negative 3 halves is negative 1.5, so on my graph, I'm going to go ahead and plot my x-intercept, so my y-intercept. My y-intercept is at 0, negative 3 halves. And I would always label that. Now, how about x-intercepts? Well, x-intercepts are going to occur wherever the function itself, y, is equal to 0. So we would have to find any values for which negative 3 divided by x plus 2 is equal to 0. Well, the answer is that there is no solution right here. Why? Well, you tell me. In fact, I will tell you that if I'm interested in finding my x-intercept, all I'm really interested in is where does the numerator equal 0? Because where the denominator, right, the denominator is equal to 0, that's undefined. Can't use that. So the only place when we have a single fraction is to set our numerator equal to 0. We're done. That's our x-intercept. In this case, there is no solution, so there is no x-intercept. All right, what about the rest of the graph? Well, we might check for symmetry. But we could say that f of x, and I'll let you review some earlier tapes on this, is neither even nor odd. And you remember that the test was to substitute in negative x for x and find out whether it's equal to the original function or is a negative of the original function. But in this case, since it's neither one, we would say that there is no symmetry that's really going to help us out. Sometimes symmetry might help us get a picture on either side of the x or y axis. That will help. But we do want to check the behavior near the asymptote. So what we're going to have to do next is we're going to have to look to see what happens as we get closer to the asymptotes. Now, what that means is that we just want to choose a few points, a few well-chosen points. And the way we choose our x values is to choose x values that get near the vertical asymptote. So in this case, what are some values? Well, we've already gone through x equals 0. We know what happens there. That's our y-intercept. Let's go to -1. Let's see what's going to happen. At x equals -1, let's see, -3 divided by -1 plus 2 gives me -3. I know what happens at -2. I get a vertical asymptote. So, -2, -3. Let's see what happens at -3. Well, at x equals -3, we're going to get -3 divided by -3 plus 2. That's -3 over -1, or +3. So this graph passes to the point 0, 3. We need to go one more point out. Let's see what happens at -4. At -4, I'm going to have -3 divided by -4 plus 2. That is to say -3 over -2, which reduces to +3/2 this time. So -4, +3.5. I can already get kind of a picture right here. What's going to happen is that as the graph goes from left to right, we're going to come up from along our horizontal asymptote of y equals 0, and the graph has to go up towards the vertical asymptote. So we're going to have our line just ferret in through those 2 points, and it's got to come up from along our vertical asymptote at x equals -2, pass through our 2 points at -1, -3, and 0, -3/2, and then start approaching the horizontal asymptote from the beneath part. So in this case, this would be a sketch of our graph f of x equals -3 over x plus 2. And the trick is, when you sketch your graph, I would point out we want to get extra points on either side of vertical asymptotes. That seems to be the key to helping us determine the behavior near those asymptotes so we can get our sketch. All right, more to come in the next video or videos.